Section 7.4 will be mostly an easy section. It has one little tricky idea at the end that's going to take some thinking, but for the most part the ideas in 7.4 are pretty straightforward. What we're talking about is combining functions, basically the arithmetic of functions. And what that means is taking two functions and adding or subtracting or multiplying or dividing, and producing a new function that's a result of the arithmetic you just did. The name of the new function it's totally self-explanatory. If the new function is called f plus g, then what that means is take the function f and take the function g and add them together. So there's f, there's g, add the two functions together, which for a simple function like this, all you're really doing is combining like terms. You get 2x squared minus 2x minus 16. Not a real challenging thing to do at all. You're just collecting like terms. If you're subtracting a function from another one, it's slightly more challenging, but only the tiniest little bit. You take the two functions and you subtract. Well, you might want to distribute the minus sign first, so there's like one extra tiny little step. But what you're doing is a fairly obvious thing. You're combining like terms again. In this case, you get negative 2x minus 14. It's kind of interesting the way the x squareds cancel out, but that's incidental. It gets a little more challenging when you start talking multiplication, because multiplication is, arithmetic-wise, a slightly more challenging operation. So here you would take x squared minus 2x minus 15, and you would multiply by x squared minus 1. And that's going to take some more work. I'm going to distribute in from the right to the left. I'm going to distribute x squared to all three of those. So that'll be x to the fourth minus 2x to the third minus 15x squared. And then I'll take negative 1 and distribute to all of that. So that'll be negative x squared plus 2x plus 15. And then I have to collect like terms, and I've got x to the fourth minus 2x to the third minus 16x squared plus 2x plus 15 for my result. That's the function that f times g turns out to be. The trickiest one, of course, is, as you probably guessed, division. With division, you take one function and you divide by the other one. So we're going to take x squared minus 2x minus 15, and we're going to have to divide by x squared minus 1. Now in this case, with division, we have not really so much arithmetic to do as we've definitely got true algebra. We have to factor and reduce. So factor out the numerator. Let's see, x minus 5 and x plus 3. Factor out the denominator, x plus 1 and x minus 1, and there really isn't any reducing there. So which form would you write your answer in? Either one is acceptable. I kind of like this one because you have to factor it anyways to see if it reduces, and then if it doesn't reduce, you can just stop, whereas the other form you would have to multiply it back out, which you could just copy down what you had a second ago, but still I like to stop where I'm finished. So I like the one on the right a little bit better. But you will notice one extra little thing happening here in this case, and that is, in the first three, adding and subtracting and multiplying, we started with polynomials and we ended with a polynomial. Here with division, we started with polynomials and we've got something different now. We have a rational expression. And what that throws into things is, now there's a denominator. Now we have a domain that matters. All three of the original ones, the domain was all real numbers. All real numbers for f, all real numbers for g, and then plus, minus, and times all produced all real numbers for their domain. But not this time. The domain we have here is everything except negative 1 and 1. And that additional restriction to the domain, that only happens when you're doing division. You don't get any extra restrictions when you're adding or subtracting or multiplying. because division is the only case where there's something you cannot do. You cannot divide by 0. And since we're talking about domain, that leads us to the part of 7.4 that is indeed a little bit challenging. And that is figuring out the domains of a combination of functions. So we've got function h here, and it has its own domain. And then we got function k here, and it has something going on with its domain. In fact, before we worry about combining them, let's just figure out their own individual domains. H here, its domain is everything except 2. You can plug in anything you want, except if you plug in 2, you're going to divide by 0, so plugging in 2 is illegal. And then this one here, the domain, well, it's a little trickier to figure out. 5 minus x cannot be negative, so it has to be bigger than or equal to 0, which ends up actually meaning that x has to be smaller than or equal to 5. And if you think about it, that makes sense. If you tried plugging in 6, you'd go 5 minus 6, and you'd be doing square root of a negative. But if you try plugging in 4, 5 minus 4 comes out positive, and everything's fine. So the domain of h, x not equal to 2, the domain of k, x less than or equal to 5, the question we're supposed to figure out here is what's the domain when you combine them? And the good news is you don't actually have to write out what the combination is and figure it out fresh. You really just have to combine these two domains. So you've got to combine it into x is not allowed to be 2, and also x has to be less than or equal to 5. You can't break either of the rules that have to be satisfied in order to get this combination function put together. Let me draw a picture of what we're talking about here, because it might help illustrate what my final result comes out to be. We're not allowed to equal 2, so there's got to be a gap at 2. And we've got to be less than or equal to 5 because of that inequality. So we end up with a picture that looks like this. Everything smaller than or equal to 5, but make sure you skip over 2. Notice that produces two intervals. There's an interval on the left that goes negative infinity to 2, and then there's an interval on the right that goes from 2 to 5. So really the best way to write up the answer here is interval notation, and it would end up looking like this. Negative infinity to 2, union with the interval from 2 to 5, including 5. This is the hard part of 7.4. The actual adding and subtracting and multiplying and dividing is all pretty straightforward stuff. It's the logic of combining the domains for the domain of the combination function. That's the part that's going to be a little challenging when you're working here in 7.4.